semester, it's a lot easier to change just the numbers, right? Okay, we have to rewrite the expression as the first power of cosine. All right. When we're finished with this one, I'm gonna give you a hint on the test. Okay. So what you're wanting to look for in your notebook is you want to look for your power reducing formulas. Flip to your power reducing formulas if you don't have them in front of you. Okay. Okay. So, oh boy, they want me to change that. Okay. So what can I replace? Whenever I see that first power of cosine or first power of trig, I want to use power reducing. So you might want to write yourself a note by this one. Power reducing. Okay. All right. What do I get to replace sine squared with? Read what it says from the power reducing formulas. And instead of u, we're going to use x over 2. All right. What am I going to replace tangent with? 2x over 1 plus cosine 2x. Okay. All right. Unfortunately, I'm going to have to FOIL this. Okay. Because I have to make sure it's down into the first power of cosine and it's simplified. So we're going to go for our FOIL. So what's 1 times 1? 1. All right. 1 times negative cosine 2x is what? And then how many times am I going to have that? Twice. So I've got 2 cosine 2x. That's still in the first power of cosine, so that's good. What's negative cosine 2x times negative cosine 2x? Cosine what? Squared 2x. Unfortunately, now I don't have a first power of cosine anymore. Okay. I'm going to go ahead and distribute that 2 in as well. So 2 plus 2 cosine 2x. All right. So it's going to get ugly here for just a second. I need to use my power reducing again right here. And you guys, on this test, for power reducing, it's hard to get around not doing it twice. Okay? I think power reducing is the ugliest, and I think it only comes up on this one problem. Okay? Hopefully I'm right. All right, 2x. So read me, what does the power reducing say for cosine? 2x over 2. Okay. I really, really, really do not like the 2. Okay? So what I'm going to do is I'm going to try to get rid of the 2. So how do I get that out of the denominator? We're going to multiply everything in that row there by 2. All right, so what's 2 times 1? 2. 2 times 2. 4 cosine 2x. All right, what happens with this 2 and that 2? Cancel. So I've got plus 1 cosine 1 plus 1 cosine 2x. All over 2 plus 2 cosine 2x. All right, what do you know about, what are we going to do with this and this? Add them. So what's 2 plus 1? 3 minus 4 cosine 2x plus cosine 2x over 2 plus 2 cosine 2x. Done. If that happened to be like a 4, we'd probably want to, well, I can't. There's no 4. If there were evens in there somehow, we could factor out, but I'm pretty sure it's not like that on the test. All right? I'm hoping that's the ugliest one we got to deal with. Okay? I don't think they get much uglier than that. Because the sine, cosine, cosine, sine stuff should be easy for us, right? All right, are we all okay to go to number 3? Any questions on that one? All right. We need to simplify the expression. This one, you guys, somebody did point it out to me yesterday. I'm going to fix this for next year. It is our co-function identity over there. It's not going to be like that on the test. This will not be a pi over 2. It'll be like 3 pi over 2 or a pi over 3 shortcut here in just a second. In fact, we're going to take it for the bottom, okay? What's the tangent of pi over 4? So what's the sine of it? Square root of 2 over 2, and this one's going to be what? Okay, so what is really the tangent of pi over 4? 1. So when I come down here to this bottom one, I'm just going to put 1. Alright, what's going to happen with those 2's right there? They're going to cancel, right? So what do I really have in that spot? And do you see how in the denominator, I don't need to write the huge mess. I've got negative square root of 3 minus 1 over 1 minus square root of 3. We're going to go ahead and let you leave that radical in the denominator for this test. So you get to, I know, we set a special magical spell to make your paper not explode. Okay, so it's okay. Alright, so you can go ahead and leave that in the denominator this time only. Alright, we good? Not so bad. It looks awful to begin with, but not so bad. Alright, yeah, take that. Alright, it tells us we're in quadrant 2. This is one of the ones where we do need to look at the triangles, so I'm going to go ahead and draw my triangles first, and then I'll write out my pattern. Okay, so I've got my 2 triangles. I've got U, I've got V. What is the ratio for sine? Opposite over hypotenuse. Okay, so what's going to go on my other leg? 4. And you guys, guess what? We're going to leave it in triples. Maybe I'll switch the sine and the cosine, or what would be really easy for me to switch out on the top, what I put on the top? 4, right? So it should be, or maybe it'll be the 6, 8, 10 or something like that. Okay, but it should be a triple that you recognize. If not, do the Pythagorean theorem. Okay? Alright, what's your cosine ratio? Adjacent, I'm going to put the negative on the adjacent. It never always goes on the leg. And then the hypotenuse is 13. What does that make my other leg? 12. It tells you you're quadrant 2, so all of our answers should look like a quadrant 2 answer. Alright, I am looking at the cosine. So what is, for this is a sum and difference because I have the adding on the inside. If it's going to be product to sum or sum to product, it's probably going to state that in the problem. Okay? So, what is my cosine pattern? Sine, sine. So I was watching the Smarter Balance during 6th period yesterday. I saw a unit circle. You excited to get the unit circle? You didn't get a unit circle? Oh, bummer. Alright, because I saw a unit circle on a problem. Alright, and it was literally just, it was like a sine like pi over 3 kind of thing. All you had to do is, wouldn't that have been a nice problem? Alright, okay, for cosine, what do we do with the operational symbol? Switch it, so we're going minus. Alright, what is the cosine of u? Did they give it to me? No, I gotta read it out of the triangle. So what is it out of the triangle? 4 over 5, good. Alright, what's the cosine of the V triangle? They gave it to me, didn't they? So I'm gonna write it down because they gave it to me. Negative 5 over 13. Alright, what is the sine of the U triangle? And they told me that, right? Okay, now reading it out of the triangle, what's the sine of the V triangle? And think about it, we're supposed to be in quadrant 2, and quadrant 2 is sine positive. Yeah, so we're good with the positive number there. Alright, what's my denominator going to be? 65. Alright, what's 4 times negative 5? Negative 20. Negative 3 times 12. I'm sorry, 3 times 12 is fine. 36. Okay, negative 20 and negative 36 is? Negative 56 over 65. You guys know how to punch the buttons on your calculator and get that to reduce? See if it reduces for me. This is not the answer that she gave us. Does it reduce? She's saying negative 4, negative 5. Oh, there's a problem. Okay, we're wrong. If this is in quadrant, we lost a sign somewhere. If we're in quadrant 2, what do we know about cosine? So see where I lost the sign? what should this number have been? Negative 16 over 65. So you really need to check your quadrants. Okay? It would have been good on here to write it as a negative there. Okay? That would have caught it for us maybe. Alright, let's keep going. Alright. Number 6 is the one we're going to cross out. It's not going to be on the test. So I'm not going to confuse you by going over it. Okay? You good with that? Okay, let's keep going then. No 6. That's the one we decided to get rid of. Okay? Alright, double angle formula to find the exact value of sine of 2u. It gives me some information. It says that the tangent is negative 3 over 4. Which quadrant is that in? 3 pi over 2 to 2 pi is quadrant what? 4. Okay, so what's positive in quadrant 4? The cosine is positive, right? Everything else is negative. Alright, let's draw a triangle for the tangent, and then we'll get into the double angle formula. Alright, so I've got the U triangle. It says we're negative 3. The negative, though, should go on the x, because we're talking about the sine value. Oh, sorry. Should go on the y. Sorry about that. The 3 is the y, the 4 is the x. Okay? What should go on my other hypotenuse? 5. Okay. Let's look at sine of 2u. So looking up the double angle formula, what does the sine want us to do? What does it say? 2 sine u, what else? Cosine u. Good. So all I'm going to do is plug into that. 2, what's the sine of this triangle? No, I was right before. It's the negative's got to go there. What's the sine of the triangle? Negative 3 over 5. Okay, now look at quadrant 2, or quadrant 4. Is the sign supposed to be positive or negative? Negative. Did we get a negative sign? Yeah. Okay, so that's how we double check to make sure we're right. Alright, what about the cosine of u? 4 over 5. Is cosine supposed to be positive or negative in this quadrant? Positive. So I have the correct signs. What's my denominator is 25. What do I get across my numerator? Negative 24. Okay. Alright. Number 8. We're going to use the double angle formula to rewrite the expression. Okay? So, what we have to look for is we have to try to find one of you guys have the double angle in front of you? Everybody get it in front of you. Okay? We need to turn it into one of the things we see in the double angle formula. I'm going to attempt to factor it first and see if something pops out. Okay? So what could I take out of this? I'm going to take out a 7. Good. What's left behind? Sine squared x. Okay, now I want you to look at your double angle formulas. Is this part of the double angle formula? Yes. Yes, which one? Cosine of 2u. What's my u this time? X. Done. That's all I have to do to it. Okay? And we tried to keep, I want to know that you understand which one is double angle, and that you can do a little bit of factoring and apply it. None of these ones that have like 10 crazy steps. Okay? Alright, we're more than halfway there. Alright, we're supposed to write as a single trigonometric function. Oh, she used power reducing again. Alright. Let's see what we can do. I would probably go... Factoring isn't going to do it for me, I don't think. Alright, I think we're going to have to use a, a power reducing on this. Alright, so let's go for the power reducing. We've got, I'm going to rewrite this as 4, just to isolate it a little bit, minus 1. Okay. distributed in, so 2 plus 2 cosine 12 alpha minus 1. What's the only other thing I can do? Put the 2 and the 1 together, right? Does it matter if I put them in the front or the back? No. Okay, I'm going to go for the front. So 1 plus 2 cosine 12 alpha. That one wasn't as bad as the first one that we did with power reducing. Slightly different application. Alright. Flip to your half angle. Half angle's coming up next here. Flip to your half angle formula. Make sure you got it in front of you. Okay. Oops, I went too many, didn't I? Okay. This is the only half angle on the test. How do we know it's a half angle? You divide by 2, right? Half of an angle is divided in by 2. So we know we're in half angle world, okay? Before I get too far, they gave me a triangle. What's going to be on this part of the triangle right there? On the hypotenuse? 13, great. Have we had to do the Pythagorean theorem once? No, it's been really nice, okay? So, you should know those triples. It's going to help you out. Alright, so we're looking for cosine of theta over 2. Alright, so on your half angle, what does the half angle start with? Plus or minus square root. Just give me the formula for now. Cosine of theta over 2. Okay, so now let's apply that to what we have, the information we have. I need the cosine of that triangle. What's the cosine of that triangle? I like the 12 over 13. Okay. If I was working smart and not hard, alright, what would I turn that 1 into? 13 over 13 automatically in that step. Okay. What is 13 over 13 plus 12 over 13? 25 over 13 divided by 2. How do I get rid of that 2? Multiply by the reciprocal. Good. Times 1/2. Okay. Now it becomes a simplifying thing. I'm going to come up here with my work. Okay. So, plus or minus. What's the square root of 25? 5. And then over the square root of what? 26. And what do I do? What do you think I'm not allowed to do in this problem? Keep the radical. I've got to rationalize. Although rationalizing like that, we almost don't need to write down the work, right? Hopefully close to that point in our math careers. Alright, we good with 10? Alright. Let's look at 11. Okay. It tells you to use product to sum. Look for that exact order of those words in your book, on the answer sheet. Okay, when you get to it. I'm gonna have a 10 hang out in front. Okay, so the 10's gonna stay in front. So if I've got a sine times a cosine, okay, what do I start my product to sum? What do all the product to sums start with? 1/2, okay? And then sine to times cosine, where am I going to go from there? Sine of the two angles, right? And we add. Then we're going to add what else? Sine, and inside those parentheses we subtract. Okay, so it's sine of pi over 12. Oh, it's pi over 12 on both of them. Okay. Pi over 12, pi over 12. Alright, this one's going to seem weird the way we're going to leave it. Okay. Okay, could I simplify this a little bit? Yeah, 2 goes into 10, 5 times, so I really have a 5 hanging out in front. What is pi over 12 plus pi over 12? 2 pi over 12, which reduces to what? so it's really sine of pi over 6. What's pi over 12 minus pi over 12? 0, so it's times sine of... So we don't want you to use your unit circle. It just look at the instructions. It says rewrite the given product. It doesn't say evaluate. Okay, and it should be obvious, hopefully, from the answer choices, if it's multiple choice. I really want to. Instinct is telling me put those numbers in there, but we're not going to. Okay? There were some like that in the book that they left like that. That's where that came from. Alright, let's try the next one. It's another product to sum, so I'm going to find that in my notes right now or on my answer page. I've got to do a cosine. Oh, we didn't really change it up on you, did we? Oh, we did it backwards, didn't we? Alright, so what do all the product to sums start with? 1/2. Okay, it's cosine sine this time. So I've got to start with what in my product to sum? Look at it. It's sine and sine, isn't it? It's still sine and sine. In the first one, I am still adding. In the second one, I'm still subtracting. The difference is right here. What is my operational symbol? Minus. Alright, and I'm going to plop in the 3 theta and the 2 theta. And the 3 theta and the 2 theta. So we have 1/2. What's sine, or what do I get when I add 3 theta and 2 theta? 5 theta. What do I get when I subtract them? Theta. Oop, I don't know why I wrote a bracket. Done. 2 lines, that's not bad. Do you see why though we made the test only 15 questions? The problems are longer, right? And they take a little bit more thought, so we reduce the number of questions. Okay? Trying to help you out. Alright, we're now switching gears. It says, watch your instructions. It says sum to product. Don't just look at the problem without reading the instructions on this test. You'll be in real big trouble. Okay? Sum to product. So I'm going to go to those formulas. I've got a cosine plus a cosine. So what do all of those formulas start with? 2. For cosine plus cosine, what am I multiplying together? Cosine and cosine. Okay, and then in here we divide them all by what? 2. The first one is always a plus, the second one is always minus, and then I've got 5 theta, 3 theta. 5 theta, 3 theta. So 2 cosine, what's 5 plus 3? 8. I think we did this one, and almost think this one was out of the notes. 5 minus 3. 2 theta over 2. So we've got 2 cosine of what? 4 theta cosine of theta. Alright. Only 3 problems left. Alright. Look at the instructions. I'm doing another sum to product. Okay? So, what do all the sum to products start with? 2. Okay, we've got a sine plus a sine. So what am I end up multiplying together? Sine times cosine. What do we divide them all by? 2. The first one's always plus, the second one's always minus. I'm going to throw 4x and 10x in there. Oh, I see a problem here. One little tiny thing that we're going to have to deal with. Okay? Alright. So, what is 4x plus 10x? 14x over 2. Cosine of what? Good. Alright, so we've got 2 sine. 2 goes into 14 how many times? 7 times. Cosine is what? Here's the thing. I'm not allowed to leave a negative inside of there. Remember these signs on the side of the room? Remember the rule? Look at the one with the negative inside of there. What happens with the cosine? It goes positive. So all I'm going to do is rewrite this as cosine 3x. And if it was multiple choice, it shouldn't be where it tries to trick you and one is negative and one is positive. I don't think we did that to you. This one might not be multiple choice. It might be an open-ended or free response. You good? 14? Alright. This is one, if you haven't been here because you were in testing, we changed this problem. So you're going to want to write this down. Okay? The one that was there was too hard. Okay? It was a homework problem, but the other teachers and I decided it was a little bit much for the test. Because we can get this one done in just a couple of lines. Alright, we're back to the sum and difference. So the sine, cosine, cosine, sine. Because we see these got two angles on the inside. Okay? So, what's my sine pattern? Cosine, sine. Alright, so sine, cosine, cosine, sine. What operational symbol am I putting? Plus. And then I'm going to plop in an xy and an xy. We did almost this exact same problem as number 1, didn't we? Only we had cosines in there. Alright. I'm going to do that half now. What is the, what's the sine pattern again? Good. What operational symbol do I get this time? Minus. So sine, cosine, cosine, sine. And I'm going to plop in xy, xy. Alright, take a careful look at it. What do you observe? Cosine, sine is gone. What do we notice about these? They're the same. How many are there? 2 sine x cosine. Did we get what we wanted? In 2 lines, we got what we wanted. Okay. Alright. Hopefully... Okay. Hopefully we, hopefully you didn't write down 16 that was up there, okay? I told you not to. I'm going to do this differently than Miss Dudley did, okay? I'm going to start by factoring this with a difference of squares, okay? So, what's the square root of cosine to the 4th? Cosine squared x. Okay, what's the square root of sine to the 4th? Sine squared x. Make 1a plus and 1a minus. Alright, we should know what cosine squared plus sine squared is. What's that? 1. Pythagoras